20 or 32. Similar figures have the same shape, but are not necessarily the same size. So you might have two rectangles that have congruent angles that have equal measures. Congruent means they are equal. If two polygons are similar polygons, then corresponding angles are congruent, which means the angles are equal, and the lengths of the corresponding sides are proportional. Corresponding means they are located in the same spot. All right, let's look at this. Triangle ABC is similar to triangle DEF. Now, you can find similarity right from here. It says, list all, I'm not going to scroll up, I'm going to answer these questions. So you'll be in your note packet. A says, list all the parts of the triangle that are congruent. Congruent looks like this. It's an equal with a squiggly. Why doesn't it just mean equal? Because angle A is congruent. Angle A is congruent to angle D. That means if this is 40 degrees, this is also 40 degrees. Why aren't they equal? Because this is angle A and this is angle D. Their measures are equal, but they are different angles. That's why we say congruent. Angle B is congruent to angle E, and angle C is congruent to angle F. And I want you to write it just like that. Now, list the parts of the triangle that are similar. Similar, this is B. Similar, you use just a squiggle. That means they're proportional, but they're corresponding, they're matching. So, we've got side A, B is similar with where AB is to side DE. Side BC is similar to side EF. And segment AC is similar to segment DF. Now, you could get all of these things from the diagrams, or you could get them up here. Look, angle A and angle D are congruent. B and C or B and E are congruent. C and F are congruent. I could do side AB and side DF, side BC and side EF, side AC and side DF. So you can get them either way. All right, now, down at the bottom of this page, part C says, set up a proportion. Use proportions to find the values of X and Y. Now, what I'm going to do, I am going to use some notation that I think will help you. I am going to circle corresponding sides. These two are corresponding. I put a circle around them. 4 and Y, I'm putting a box around. X and 35, I'm putting a triangle around. So I put a shape, a matching shape around corresponding sides. Now, to solve this, to find X, I am going to set up a proportion. So, I'm going to start with my shape on my left, and I'm going to do X over 3 equals, that's what I'm doing, X, which is a triangle, over 3, which is a circle. What do I have in the triangle over there? 35 over 15. I am setting up a proportion with similar shapes. X over 3 is the same as 35 over 15. Now, I can do it another way. I can do X over 35 equals 3 over 15. As long as I'm following the same pattern on both sides, it does not matter. I did one triangle on this side, the smaller one, and then the bigger one. This one, my pattern was small, big, one side, small, big, another side. Either way, it's going to work out the same way. So, to solving proportions, again, we cross multiply. 15 times X is 15X. 3 times 35 is 105. How do I solve this? I proportion to solve for y. So, to solve for y, I'll go from this triangle over here. So, y over 15 equals, what's the matching or the correspondence pot? 4 over 3. Let's solve the proportion. 3 times y is 3y. 15 times 4 is 60. Divide both sides by 3. Y is 20. So I found my 2 missing sides. All right, let's try this one. Trapezoid A, B, C, D is similar to trapezoid E, F, G, H. When you read the directions, you need to make sure that the diagrams are set up exactly the same. A, B, C, D, E, F, G, H. So they are relative to each other. Use a proportion to find the values of x and y. So I'm going to circle the 5 and the y plus 4, because those are in corresponding spots. I'm going to put a box around these two, and I'm going to put a triangle around these two. So my proportion to solve for, let's do y first. I'm going to do y plus 4 over 48. So I did circle over triangle, and over here it'll be 5 over 24. Circle over triangle. Yeah, let's cross multiply. So when I cross multiply, I'm going to have to do 24 times the quantity y plus 4 equals 48 times 5 is 240. Now, how do I do this? I use distributive property. So I'm going to have 24y plus 96 equals 240. Subtract 96 from both sides. 24y equals 144. Divide both sides by 24, and you end up with y is 6. So I go y is 6. All right, let's set up a proportion to find x. So I'm going to do 2x over 24 equals x plus 12 over 48. Cross multiply. 2x times 48 is 96x. And 24 times the quantity x plus 12. Now, if you are in my single period regular pre-algebra, we will not do this problem, only do the y. Use distributive. 96x equals 24x plus 288. Subtract 24x from both sides, and I end up with 72x equals 288. Divide by 72, x is 4. Now, once we've done that, part B, it's asking us to find the length of the sides. So, I'm going to write here, x is 4. So, let's go back and look at our diagram. The length of side BC, BC is 2x. Well, x is 4, so 2 times 4 is 8. I need to find side EH. EH is y plus 4. Y is 6, so 6 plus 4 is 10. And our last side at G is x plus 12. x is 4, so 4 plus 12 is 16. So once I found the values, I wrote my equation. All right. Last example is triangle ABC is similar to triangle ADE. I'm going to draw them separately. A, B, C. So I'm taking the little triangle, which is 3, 4, 5, and writing it there. My big triangle, A, D, E. This side is Y. This side is X. And this side is 12.5. So, 3 matches up with Y, corresponds with. 4 matches up with X. And 5 matches up with 12.5. Corresponding parts. So, let's write a proportion to find, let's do Y first. So y over 12.5 equals 3 over 5. And then when you cross multiply, you'll have 5y equals 37.5. Divide both sides by 5, and you end up with y is 7.5. Okay, let's set up a proportion to find x. So I'm going to start in this triangle. X over 12.5. That over that equals 4 over 5. Cross multiply, and I'll have 5x equals 50. Divide both sides by 5.